we're looking at some shapes today. So usually I have someone come up and do this on the board, but given the year, I'm going to just point and wait like 2 seconds, and then we'll decide where it goes, all right? So polygon or not? Yes? Again, wait just a second to let everyone actually see and decide. There's no in between, but I'm hearing more no's than yeses. Arlen, is this yes or no? Arlen says yes. If we get it wrong, it's all his fault. All right, how about this one? No? Yes or no? All right, any issues with any of these? Any other issues? Nobody has any other issues? Which one? Does it have a color? Who thinks that this one should be a polygon? So we're gonna keep it no because that's where more answers are. I'm not saying it's yes or no. Any other ones? Yeah. Anyone agree, disagree? No, you're not supposed to look up there. All right, we'll take a class vote. Who thinks that this one should stay? Polygon, raise your hand. Who thinks it should get moved? All right. Some people voted twice. And also the leaving it one, but they are wrong. All right. All right. All right. So could you come up with a general idea of a definition for a polygon off of this? No. Not from the yes. Equal to what? Yeah. What was that? These ones do happen to be symmetric. They don't have to be. That is something that I should probably change in the activity, so thank you. I don't usually get that. What has to be true about the sides? You think all the lengths in this one are the same? These little things are the same as these? So lengths don't have to be the same, right? Why is this not a polygon? Okay, why isn't this a polygon? What's actually wrong with this one? The half circle. What's wrong with the half circle for a polygon? Polygons have to be straight lines, right? So it has to be made up of segments. Why doesn't the basketball work? It's actually a sphere, right? Why does this one not work? It's not closed. There were 2 of you at least that voted for it to be here. You think it should. Yeah. Yeah, it closes at a midpoint. It crosses itself, right? Do any of the other polygons do that? No. What about this one? There's a line extending. So what is it not doing that all the other ones do? It doesn't end at the end point of segments, right? All right, so our actual definition, if you already know this, you probably wouldn't need to write it, but you probably need a little bit of it. Polygon is a closed figure. We talked about that. Formed by a finite number. We did not talk about that, but that's interesting. Of coplanar segments called sides. So in segments being flat, straight. We didn't talk about it being coplanar, except that we already said that most of the things we talk about this year will be. Sides have a common endpoint and are non-collinear. Each side intersects exactly 2 other sides, but only at their endpoints, right? So that's what's wrong with the one that crosses itself and the one that ends not at the end. My guess is that you don't need that the vertex of each angle is the vertex of the polygon. Polygon named by the letters. If you need it, write it. I would think that you don't. It's going to be how we name pretty much everything. They do need to be in consecutive order. So it gives an order there, but that doesn't have to be the order you give, just that they have to be in an order. I only ever put them up because someone said there's nothing on my walls, and these were already here. What? Oh. Yeah.
Because I need this because when I look up, when I'm doing it past, I'm like, oh, I don't know what I'm talking about. And then I look up there, and I'm like, oh, Emily, don't say that. Emily, he's gonna hide from you. I didn't use any of those. Those were not pulled off. Ankles. I just died.
All right. As I mentioned, I think the most interesting point of the polygons part here is it is formed by a finite number of sides. The only other choice would be infinite. So this is just saying that it can't be an infinite number of sides. There is a shape. I almost said polygon. It's technically not a polygon that does have an infinite number of sides. It is, in fact, a circle, yes. Oh, yes. So again, it kind of breaks definition, but it comes from an understanding or lack of understanding what infinite actually means. So infinite is not a number. So what you would be doing if you made an infinite number of sides is by making an infinite number of sides, you are making the length of each side infinitesimal, right? Meaning that it's actually extremely small, right? No matter how big your actual thing is, right? If there's an infinite number of sides, that means each side is infinitesimally small, which basically, to put it very briefly, right? Basically, if you get small enough, right, it actually doesn't have a shape or a size. It is just a location and it becomes a point, right? And points that are equidistant from each other form a circle. What was that? Um, in a way, yes. Yeah, and again, a circle is not a polygon, so neither of them would be. Um, if that interests you at all, you may look at the book Flatlands. I don't really highly recommend it. It is referenced pop culturally. I like put together pop and culture and made pulp. Um, it is mentioned or used in pop culture here and there. I guess when I say pop culture, I mean it was in things while I was growing up. It's a much older book than that. So the only one that I can give you for sure is that I know that it was in the TV show Futurama. They reference Flatlands when they're going through the what is that quantum Mobius whatever. The, what? What did? I think it's older than that. The Simpsons is real old. All right. Convex and concave. Futurama, they do drifting, so they get stuck in like an infinite drift or something, and somewhere in there they get. I think that's the one it is. They get caught in flatlands. Convex and concave, right? You can do it like it says there by extending the sides. If you extend a side and it crosses through the middle, then it's concave. Otherwise, you can think of it much more simply than this, right? If it caves in on itself, right? So there is a cave formed here. That is an easier way to remember concave, right? There's literally a cave. Well, I mean, the figure that they're actually dealing with here is more like that, but equal sides and stuff. And then they're extending one of the sides. Yes. Well, I mean, if you draw it like that, then you're no longer a polygon. But if it were just the outside sketch of it, then yes, it would be con. No, it's hotter outside than in here. But I don't know why my. I mean, I have my AC set to 68, so. All right. Again, if you know these terms, you don't necessarily need to write them. Equilateral, the first part of the word is equal. Lateral is in relation to sides, right? So literally the word says it has equal sides, right? Angular, equal angles. So again, you don't need to write the whole thing. Even if you wrote equilateral polygon, you might just say sides are congruent. Or if you're like me, you would make it even easier and not write congruent and do that. You might not write angles. You might simplify to angles and congruent. And then regular is when both of those are true. Triangles don't work as good examples here. We'll explain that in a minute. So as my examples, I'm going to use quadrilaterals. So our first one here, equal sides. Might be something like this. It is a special type of parallelogram. That's going the opposite direction. It's not regular. Diamond is not a shape in mathematics. It is a rhombus. All right, equiangular quadrilateral would be a rectangle, and regular is a so it's not that a square doesn't work as examples for the other two. It's just that if you use it, then you don't recognize that a equilateral quadrilateral does not have to be a square. Yes, Nick. So the problem with an equilateral triangle is that it is always equiangular and it's always regular. So the problem there is if I draw equilateral, yes, I can do it without showing equiangular. It doesn't work as a great example because it'd be like drawing the same triangle 3 times and you're like, so what's the difference? Yeah. Yeah, any other one can be one and not the other. A triangle can't be one without being the other. Again, I could use the example and just do it like there, and then you'd be like, oh, that's fine, right? But I like the quadrilaterals better. What was that? Yeah, you could. I try to use the simplest figure without being too simple. All right. The next slide, we're going to be dealing with the names of polygons. So the smallest polygon you have is called a least amount of sides probably is what I should have said, right? Least amount of sides is called a triangle. It does have another appropriate name, though we don't use it. I'm not sure why. It can also be called a trigon. Look it up. It is almost never used, except there is a word that has it in it, which makes it important. So there is a word that starts. There is a word that starts trigon. Trigonometry, right? And you see the word trigon there because it relates to triangles. Trigon actually almost makes more sense because all of the other things that we label, all of the other ones talk about sides, not angles. So if it's a polygon, they're going to have the same, right? The 4-sided is quadrilateral. 5-sided is pentagon. 6-sided is hexagon. 7 is a heptagon. We'll talk about sept in a second. So that's 7. Both are 7. 8 is 9, nonagon, and 10 is decagon. After that, you don't need to know anymore. So you don't need to know hendecagon is 11 and dodecagon is 12. Given the naming system, you could keep naming stuff all the way through, and they do have names. However, once we get to 11, you are allowed to start calling it an 11gon. 12 would be a 12gon. 24 would be a 24gon. It has 24 sides and 24 angles. All right, so this is the list. If any of those are ones that you don't know up until 10, you should write it down. Dodecagon. What? It has to do with which base language we're taking most of these from. And since it is, it's Greek versus Latin, I believe. So they're very, very related languages. However, they are not the same. And so I believe hept comes from the Greek, if I have to guess, and sept would come from the Latin. There's a reason why I think it's that way, but I can explain in a second. Yes. What was that? Yes. So like a polyhedron would be like your die, right? And then regular polyhedron are actually pretty interesting. Those are what we mostly use for our die. All right, going through these quickly. Try, right? You see the number 3, quad, and then lateral is sides, right? So quadrilateral, think equilateral, right? 4 sides, equal sides. Where else do you see the word pent? Know the word pent from? So there is a pentagon, right? The Pentagon in Washington is a 5-sided building, right? Where else? You have the, if you have a penthouse, right? This one I did not know. It's not a 5-story house. This one I haven't looked up, so I'm going to say why I think it's called a penthouse rather than this is why it's called a penthouse, right? Where is the penthouse on a building? It's the top floor. The penthouse of an apartment building or a condo is the top floor. So the top building, the top part of the building might have a penthouse, right? Why is it called that? How many sides does it have? And then it also has the roof, right? So I'm not 100% sure. That is just what I believe to be true. It makes sense to me. Where else do we see hex? So if you use tools at all, there are some screws that use a hex tool, right? All right, now to get to ones that are more interesting. What? How many sides does it have? So how many sides does it have? That's what it is. So if it has 12 sides, it's a 12-gon. 12 is n. However many sides it has is n. So if it has 12 sides, then it's a 12-gon. If it has 24 sides, then it's a 24-gon. If it has 158 sides, then it's a 158-gon. All right. You can't call it an 8-gon. You have to call it octagon. All right. Getting into the ones that are interesting. Hept. So we talked about this. That's not hept. That's HEPA. So we talked about this. Sept, right? Sept is the same. So we have September, which is the.
It's not the 7th month, it's the 9th month.
Yeah, who said 7th?
I would know this very well.
All right. And then after September, we have October, which is the. It's the 10th month. You don't know your months. After October, we have the month of November, which is the 11th month. Thank you. And you guys need to stop talking. All right. And then we end our year with December, which is clearly the 12th month. So you're thinking to yourself, Mr. Poppy, why are you bringing up things that clearly don't relate to what we're learning? This is not helping, right? I bring it up more as an interesting fact, right? So why are the months of the year off by 2 months? So why is September the 9th month, not the 7th month like it's supposed to be? Victoria, did you say something? It's not the Mayans. I can't hear you. Latin. So, as I mentioned, we're off by 2 months. That means 2 months were added, right? How did 2 months get erased and we added 2 to the... All right. So what 2 months were added? It is not January and February. It is not March and April. July is one of them. And the other is August. All right, so why were these 2 months added? I spelt it like it should be spelled with an I because otherwise Julius doesn't get spelled correctly. I believe if you go into other languages, I believe German does actually spell July, Juli, which makes a lot more sense because they're taking it from someone's name, right? So people thought that they were so important that they could break the way the calendar works and not follow months correctly anymore. All right, you probably don't want to copy down the first one here. Name each polygon by its number of sides. Classify as convex, concave, or regular or irregular. Keep your feet to yourself. On the floor. Nonagon? No or no? Convex or concave? Convex, none of the sides go in on themselves. And regular or irregular? Second one is a hexagon. It is concave. It has a cave here. If you extend this side, it does go through the middle. Every concave polygon is always irregular. If it is concave, all of the angles cannot be equal, right? This angle and this angle cannot be equal because that one's more than 180, right? To make concave, it has to happen. Last one here is a quadrilateral. It is convex and irregular. Do we know all the sides are congruent? Do we know all the angles are congruent? No and no. Perimeter, circumference, and area. Again, as long as you know what these words are, the next side will give the actual equations that you need. Perimeter is the length around, circumference is the distance around, and area is the square units. Perimeter and circumference are the same thing. We just say circumference when we talk about circles. You will find that that is not true everywhere. Some places call it the perimeter for both. The only thing that we change, we make it which relates to a circle, right? So there's part of it that makes sense, but probably unnecessary. Again, if you know these formulas or if you know any of them, don't write them down. Only write ones that you don't know. The ones that I'd be most likely thinking that you might not know, maybe triangle area, but perimeter you should know probably. Circle, 2 pi r and pi r squared. right? If you don't know them, you might want to write those down. I would need to look it up. What public school? Yes, it's probably that it is algebra and geometry and trig all put into one class. So rather than having, and pre-calc all put into one class rather than having them separated. So like rather than doing algebra and then another year of algebra later and geometry as like a break year from it and pre-calc after, all of those things happen as they're happening would be.
Amanda, wake up to the office at the end of the day. Amanda, wake up to the office at the end of the day.
Most other countries do math that way. We're actually fairly unique in having it separate. You can get a much better progression. I'm not going to stay up here. A squared plus B squared equals C squared. We already used that this year. So if you needed it, it should already be in your notes. That's for right triangles. So we have perimeter and area. Perimeter is the sum of the sides. So 21 and 21 is 42. And then our area. (40 and 28). 4 times 10 is 40. 4 times 7 is 28. 40 and 28 is 68. It says round to the nearest tenth. More often than not, I am okay with you leaving it in pi. So the first one is circumference. Circumference is 2 pi r. Our radius is 7. 2 times 7 is so 14 pi. Again, if it's on the computer, you might need to put it to the rounding to the nearest tenth. If it's just on paper, I'm okay with 14 pi. Area, r squared is and we don't quite have enough time to do the triangle. Well, we probably do. Perimeter, this is 8.1, right? These two sides are congruent. So that's 24.2. And then it's just 1/2 the base times the height. That's 4 times 7 is 28. Right? Homework should be listed on Canvas. We will not plan on grading it tomorrow. However, you will have another lesson tomorrow with a homework assignment that will be due on Wednesday. My plan is that the lesson will take shorter than a normal in-class lesson because there are things I can do in class, like make fun of you for not knowing that September is the 9th month of the year. That comes across as mean, or if it's recorded, well, this was recorded, so. uh, again, with a recording, my plan is to keep it to 20 minutes or as close to that as I can. You should still be listening to me, right? 20 minutes. It will be played on the smartboard. And the last 20 minutes, then, the plan would be that you would have some time to work on either of the homework assignments and get some stuff done. So that's the plan for tomorrow. If you're not here by the time school starts, and if you're not here by the time school starts or very early in the day, should be the video that you're going to watch. So it should be posted fairly early and you should be able to do it. So nobody really should, even if you're not here tomorrow, fall at all behind from it. Yes. Good, thank you.